Today we are talking about power supplies for our Maker projects. We are giving USB chargers a second life and we find out which ones are the best. The devices are actually getting a second life cycle, and that saves money and helps to protect the environment. Like many of you, I have a lot of USB chargers lying around and I would like to use them for my Maker projects. Unfortunately, there are some limitations. And I have to warn you anyway about the very cheap devices that are often not safe. I don't own any of these simply because I don't want to die early. As examples for my tests, I have some Arduino projects that can be powered via USB. By the way, there are videos on the channel where we are publishing the concept, the build and the code of all projects that I'm talking about here. It might be worth subscribing to Electronics Unmessed. It also helps the channel if you use the affiliate links below for your orders, no matter what you are finally buying. Of course, Amazon won't tell me who you are and what you bought. There is only a small commission for the channel. I pimped an old RSSI meter with an Arduino Nano and an AD8318 RF sensor. It covers now a much larger power and frequency range, and it got useful features such as peak value, average duty cycle or data logger functions. The device is drawing a current between 134 and 136 milliamperes. And then we have a second version of the RSSI meter. This one utilizes a NeoPixel ring as a display and therefore draws a higher current of 240 to 248 milliamperes using its default settings. You can vary the brightness of the NeoPixels within a certain range using control commands. However, I limited the maximum brightness in the Arduino code so that the power consumption does not exceed 350 milliamperes, corresponding to 1.75 watts. And then we have a small web server that is based on an ESP32 LoRa board. The board that includes a small LED display draws around 140 milliamperes when idle. As soon as you access the website, the Wi-Fi adapter becomes active and then the current increases to 235 milliamperes. If multiple browsers access the website, the current increases by an additional 100 milliamperes. No problem with this project, but we need to keep an eye on the power consumption of the Wi-Fi adapter. And now we are having two stylish gauges that are consuming pretty low power. Both projects are based on the Arduino Nano and an X27 stepper motor. Drawing about 46 to 68 milliampere, the power consumption is about 340 milliwatts. Now we are coming to a project where I experienced limits for some chargers. I just extended the lap counter project for slot cars by a number of LEDs and some cool features. The project is based on an ESP32 development board. The Wi-Fi adapter is also used here, so we have to expect sporadic current increase of over 100 milliampere, similar to what we have seen before. In addition, there are two relays, two infrared proximity sensors and a number of red and green LEDs connected. We measured a maximum of 389 milliamperes as the average current, but there is a risk of current peaks of over 500 milliamperes, and that may be too much for a USB charger. I would like to give you a tip. It is worth using electrolytic capacitors in your Maker project to stabilize the voltage. The capacitors are smoothing the supply voltage and bridging high current peaks in order to avoid malfunctions. We see the latter happening in this clip. The microprocessor freezes during the startup process, when using a weak USB charger. Fortunately, almost all my USB chargers work with the projects shown. Only the one which was actually designed to charge small headphone batteries cannot deliver the current for the lap counter. But I can still use it for other projects. The USB standard is over 20 years old and it is still being developed further. In your junk bin you will probably find mainly chargers from the first 3 generations. Most of these will be of the 500 milliamps or 2.5 watts class, and they will generally work well. Projects consuming less than 100 milliamperes will also work with the weakest class of USB chargers. By the way, a USB interface of a PC is also delivering 500 milliamperes. USB 3.0 can deliver more power, but I wouldn't rely on it. Here is an overview on all my test results for your reference. I have added a power bank to the list because it is also an interesting USB power source. And we will see in a minute how long the projects can run on one charge. While experimenting, I discovered a different problem which limits the use of my power bank somewhat. My power bank is automatically switching off the power as soon as the current drops below 50 milliamperes for a few seconds. My power bank is 10,000 milliampere hours, and every time I use it, I'm wondering how long the connected device could run on it. The calculation is a little complicated because the charge capacity of power banks is always based on the 3.7 volt level of the lithium-ion batteries and not to 5 volts. This is a bit misleading. Dear manufacturers of power banks, how is someone having no techie background supposed to understand this? I converted the charge capacity to 5 volts using the energy capacity. And yes, at 5 volts you get less milliampere hours compared to 3.7 volts. I estimated the efficiency of the step-up converter to calculate the running times. For example, my RSSI meters are in this range. So they would easily run for 1 or 2 days with my 10,000 milliamperes power bank. Also, the lap counter would be well supplied by the power bank for a slot car racing weekend. How is about higher USB standards that can deliver higher voltages and currents? The USB standard has been extended. However, the control for higher voltage and higher currents are a bit complicated, so I wouldn't recommend this solution for maker projects today. Maybe later, when there is an inexpensive configurable breakout board available for the higher USB standards. In case you need a more powerful supply, for example for a larger NeoPixel array or for stepper motors, then I recommend you either buy one or build one with a 7805 voltage regulator. I provided a few links under the video. Many USB chargers are suitable for our maker projects. As I said, be careful with devices that are offered for very little money, as they often don't provide adequate protection against electric shock or overheating. USB chargers from the quality brands are usually the most secure ones, and typically they are also providing a more stable voltage. I hope you were able to take something away for your own maker projects. See you next time. Now stay tuned and don't forget to support the channel. See you soon in the coming episodes.